Welcome to week 13, question 1, and this is the last concept that we're going to be looking at this semester, and it is the consumers and producers surplus. So you can see here that we have two curves, and in some cases it's two lines, but we have a supply curve and a demand curve. And we looked at this earlier in the semester where we found that equilibrium point, that place where the supply curve crosses the demand curve. So it's a equilibrium point is a point they have in common, and that would be the first thing that you'd need to do in order to determine what the consumers and producers surplus is. Now, consumer surplus, you can think about it as, you're a consumer and you're going out to buy something, and you find that something that you were willing to pay $100 for is actually available to you for $75. So the consumer surplus is that difference between that $100 you expected to pay and the $75 that you actually paid. So that $25 is your consumer surplus, or that amount of money that you have kept in your purse or in your wallet. Conversely, a producer's surplus is where a producer has a certain cost in mind that they're looking to realize for a product or service, and because of a great demand in the market, a consumer is actually going to spend more to get that service or that product. And so the difference between what the producer thought they would get from for their product or service and what the consumer actually paid for it is the producer's surplus. So for example, if you've got a new cell phone that you're looking for and it costs $700, but the demand is so high that they're so hard to find that you're willing now to pay $100 more, say $800 for that same cell phone. So the difference between the $700 that the producer intended to get for it and the $800 that you actually paid to get this high demand product is $100, and so that's what the producer's surplus would be. So how do we find that? So here in question 1, we have two functions given. We have the supply function and the demand function, and it says here to graph them. So these are just two lines. You would graph them and you would see where they cross, and that would give you the equilibrium point. So we can find the equilibrium point in two ways. We can find it from graphing, or we can find it algebraically. So in this case, we're going to find it algebraically. So let's go to the next page and we'll look at how that's done. An equilibrium point is where SQ equals DQ. So we literally just set those two sets of terms equal to each other and solve for Q. So we have 1/2 Q plus 1, and it must be equal to -3/4 Q plus 16. Now at this point you might be saying, oh no, not fractions. You can leave them as fractions if you're comfortable. These are terminating decimals when they're converted, so you can also use decimals to solve this question. But either way, you're going to be gathering like terms, so the Q terms and the constant terms, and solving for Q. So here we have 1/2 Q plus 3/4 Q is going to be equal to 16 minus 1. So here we have 1/2 and 3/4 Q, so that's going to be 1 1/4 Q, or 5/4 Q, is going to be equal to 15. And then we can see that Q is equal to 15 times 4 divided by 5, and that's 12. So that is going to be your Q0 value, your quantity at the equilibrium point. And now we're going to solve for P, or the equilibrium price, by substituting Q equals 12 into either of the original equations, and I'm going to choose to substitute it into the S at Q. So S at 12 would be 1/2 12 plus 1. So half of 12 is 6, plus 1 is 7. So 7 is going to be your equilibrium price. And And the equilibrium point then will be 12,7. Okay, so that's the first step. We found the equilibrium point, and now we're going to be using our consumers and producers surplus functions in order to find out the value of them. And we're going to be going on the next page. We'll start with the consumer surplus, and the function looks like this. You have the integral. We're evaluating it from the equilibrium quantity to 0 of the demand function minus the equilibrium price. And this dq just means that we're taking the integral of that, of this, that is the derivative. So if we are going to look at it, this is meaning that we're evaluating the integral. This is the the equilibrium price. And this is the demand function. Okay? I don't want you to get bogged down in all the sort of math language, but that's essentially what you have to do. So we are evaluating from 12, which is our equilibrium quantity, to 0 of negative 3/4 Q plus 16. I'm going to put that in brackets, minus 7. Okay, so that's what we're looking at. So we need to find the integral here. First thing I should do is take this 16 and subtract the 7. So negative 3/4 Q, 16 minus 7 is going to be 9. Okay, and that's going to be negative 3/4, so we knew we had a q squared plus 9q, but here we had negative 3/4 was arrived at by multiplying something by 2, so now we're going to divide negative 3/4 by 2, and that gives us negative 3/8. And so this is the function that we're going to be evaluating from 12 to 0. Okay, so let's do that on the next page. So we have negative 3/8 times 12 squared plus 9 times 12, and we actually would be subtracting the same at 0, but each term has a q in it, so that would just be 0. And when we evaluate, we find that this equals 54. So this is our consumer's surplus. And what this means is that the consumer is paying $54 less than they had intended to pay, so that is their surplus. And now let's look at the producer's surplus. So the last thing we need to do here is find the producer's surplus, and again we're going to be looking at integration. So we're going to be integrating, and again from the equilibrium quantity to 0 of the equilibrium price minus the supply function, and dq just means we're going to integrate this derivative, and we're going from 12 to 0. Remember that our equilibrium quantity was 12, our equilibrium price was 7. So we're putting 7 in here for the equilibrium price minus the supply curve and its supply function, and it's really important to put this in brackets because this negative sign has to apply over both of these terms. So here we have 7 minus 1. If you didn't have the bracket around it, you might say that you have 7 plus 1. You might make a critical error there. So it's integration from 12 to 0. So we have 7 minus 1. We have 1/2 x plus 6. And then we're going to need to find the integral. So we have an x squared term plus 6x, and then we have something in here. We have -1/2, and the -1/2 was arrived at by multiplying something by 2. So that would be -1/2 now divided by 2, so that would be -1/4. Just think about it, if you have half of something and you divide that half by 2, then you've got 1/4 of what was the original amount. So this is what we've got now. And just now we need to substitute x is 12 and solve. I have -1/4 and 12 squared plus 6 times 12, and then of course we'd be subtracting the same with x as 0, and that would just be 0. And so if we solve for this, we find that we have a value of 36. Now reminder, we're looking at our producer surplus, so that means that the producer is gaining an amount of $36 over what they had anticipated getting from that supply, that service or product.